Okay, let's dive right into this explainer. Today, we're completely demystifying double displacement and precipitation reactions. Look, if you've ever looked at a chemical equation and thought it was just a bunch of dry, boring letters, stick with me. We are going to bring the chemistry right off the page today, and trust me, it's actually pretty cool once you see it in action. Picture this. You've got two completely clear liquids in separate test tubes, right? I mean, they look exactly like plain old water. But the second you pour one into the other, boom! Almost instantly, this thick, white, cloudy solid just materializes out of thin air and starts sinking to the bottom of the glass. It honestly looks like a magic trick. So what in the world is happening on a microscopic level to create a sudden solid out of two clear liquids? Well, the secret behind that sudden cloudy solid is what we call a double displacement reaction. Basically, this happens when two compounds exchange their ions to form two entirely new compounds. I actually like to think of this as a microscopic, perfectly choreographed partner swap. You start with two bonded pairs, they mingle for a second, and then they leave the reaction with completely different partners. Simple as that. Now, what's really interesting here is looking at the before and after. If you look at our original compounds, the reactants, and compare them directly to the newly formed compounds, the products, you can trace exactly how these chemical partners traded places. The positively and negatively charged ions just switch up their alignments, and suddenly you've got two completely new substances that look and behave totally differently from what you actually started with. And that brings us perfectly to our core reaction example for today's explainer. Let's walk through this absolutely classic equation. We've got Na₂SO₄ plus BaCl₂ giving us BaSO₄ plus 2NaCl. Let's explicitly ID the players here. On the left side of the arrow, we've got aqueous sodium sulfate and aqueous barium chloride. And hey, just a quick reminder, that AQ means aqueous, meaning they are dissolved in water. These are exactly those two clear water-like solutions we just imagined mixing together. Okay, let's break down the mechanics step by step. Step 1, our two clear solutions mixed together. Step 2, the sodium sulfate and barium chloride hit the microscopic dance floor and enthusiastically swap partners. The sodium literally drops the sulfate and grabs onto the chloride, while the barium drops the chloride and sweeps up the sulfate. And finally, step 3, we're left with two brand new chemical couples, barium sulfate and sodium chloride. It's basically the ultimate chemical square dance. Now, let's shine a massive spotlight on one of those brand new products, barium sulfate, or BaSO₄. Remember that opening micromystery? That sudden white cloudy solid dropping to the bottom of the tube? Well, here is your culprit. Barium sulfate is formed right after the molecular swap. But here's the catch. Unlike the starting materials, it is entirely insoluble in water. It physically cannot dissolve. And because it's insoluble, it just crashes right out of the liquid state as that highly visible white solid. Which actually brings us to a really crucial piece of terminology. You'll hear this exact process called a precipitation reaction all the time. It's essentially just a secondary name for this specific type of double displacement. Why? Well, because a solid insoluble precipitate, which in our reaction example is the barium sulfate, is actively formed and drops out of the solution during the swap. So double displacement describes the actual mechanics of the swap, while precipitation reaction describes the visible solid result left behind. So what does this all mean for you, especially if you've got exams coming up? Well, knowing this exact reaction example is literally a cheat code for easy marks. This brings us to the CBSE 2-mark exam strategy. Mastering the ins and outs of this specific sodium sulfate and barium chloride reaction isn't just some fun visualization exercise. It is highly strategic, incredibly practical, and absolutely crucial for your upcoming tests. Take a really close look at this quote here. This is a super common 2-mark CBSE exam question pulled straight from past papers. It says, when sodium sulfate solution is treated with barium chloride solution, a white precipitate forms. Name the reaction and write the balanced equation. This isn't just a question, guys. It's a strategic puzzle. And thanks to the visual breakdown we just did, you are now fully equipped with literally every single piece of information you need to solve it on the spot. And here is your immediate payoff, the 2-mark answer key. First, you name the reaction. You just confidently write down double displacement or precipitation reaction. Bam, point 1. Second, you write the balanced equation exactly as we studied it in our core reaction example. Na₂SO₄ aqueous plus BaCl₂ aqueous yields BaSO₄ solid plus 2NaCl aqueous. Bam, point 2. By committing this specific reaction example to memory, you know exactly how to nail those maximum points the second you see these compounds on your paper. No guessing required. So we've completely conquered double displacement and those cloudy solid precipitates. But this actually leaves us with a pretty massive, thought-provoking question to close out this explainer. What happens when reactions don't just swap partners, but actually involve the direct transfer of oxygen? Now that question takes us into a totally different molecular game with its own wild rules, redox reactions. And that is exactly what we'll be tackling next time. Until then, keep visualizing those molecular partner swaps.